Hello everyone. Today in this second session, now we will discuss the lubrication system of the IC engines. Engine lubrication system, a system which reduces friction and wear between the components in an engine, is known as lubrication system. So, in this discussion, we will try to focus what are the different lubrication systems that can be utilized in engine. Friction is the major parameter because of which we have to employ the lubrication system in the engines. Now, where we are observing the friction. In engine, there are number of components which are having the relative motion between each other. Because of this, the friction is getting increased between the components. So, there is a need to create the lubrication for the components which are having the friction in between them. So, in engine, we are having the different components which are having the sliding as well as the rotating motion. So, because of which they are creating a friction or rather the frictional losses for the engine. Normally, engine friction is calculated based on the friction power. Likely, we know that friction power can be difference between the indicated power and the brake power. So, with this difference, you can find out what is the friction power which we have observed in the particular engine. A typical engine must be designed in such a way that it will not allow total friction loss more than 30% of the total energy input. So, this can be achieved by the proper way of lubrication in the engines. Now, we will see what is the function of any lubrication system. So, very first thing is that considering the major parameter as a friction has to be get reduced by the lubrication system, and to overcome with this, a proper lubrication system can be employed. So, which will definitely avoid the energy loss as well as it will increase the life of engine. The second function of the lubrication system is to provide the sealing action. To be specific, lubricating oil helps the piston rings to maintain an effective seal against the high pressure gases in the cylinder. Definitely these high pressure gases are occurring inside the cylinder after the combustion. So, to avoid the leaking of these gases into crankcase, oil sealing can be useful in case of the piston. The third function of the lubrication system is that to carry out the heat energy generated inside the engines. As we know that there is a separate cooling system utilized to carry out the heat energy generated inside the engine. But along with the cooling system, lubrication system also helps in carrying away the heat energy which is generated inside the engine. The next function, you can observe that cleaning of the surfaces of the engine can be also carried out by the lubricating oil. In this case, cleaning means the carbon deposits or the metal particles which are settled down inside the sump or at different locations inside the engine can be taken away by the lubricating oil. The next point is, what are the principal friction surface or the major components where we have to focus as far as the lubrication system is concerned. The first component is piston and cylinder, definitely. Then we are having the crankshaft and its bearing, crank pin and its bearing, wrist pin and its bearing, as well as valve gears. So these are the major parts where we have to focus for the lubrication system. Now, when we are going for the lubrication, we have to select the lubricants. Now, while selecting the lubricants for the lubrication system, what property a particular lubricant must have, that also we have to observe. So, here are some properties which are listed to identify the better lubricant. The very first property about the lubricants is the viscosity. Viscosity is the measure of the resistance to the flow or internal friction of the lubricants. In parallel to this viscosity term, viscosity index is the governing factor while selecting the lubricants. It is used to grade the lubricants. Viscosity is inversely proportional to temperature. So, if temperature increases, viscosity of lubricant decreases, and if temperature decreases, the viscosity of lubricant increases. So, for better oil selection, you have to identify the oil which will have the high viscosity index number. So, definitely there will be a very small change in the viscosity of oil with respect to temperature. Next, we are having the property which is oilless. Oilless is nothing but the property of lubricating oil to spread and attach itself firmly to the bearing surfaces as well as to provide the lubricity. So, generally, the oiliness of lubricating oil should be high, particularly when it is used for, you can say, the contacting surface subjected to high intensity of pressure, or you can say smaller clearance which will be available between any of the two components. Next, we are having the high strength property of the lubricants. Definitely, any of the lubricating film which is exactly placed between the two components which are having the relative motion between them. If this particular lubricating film doesn't acquire a high strength, definitely because of the forces which are getting applied on each other by the different components or the relative components, they may create the impression, or you can say scuffing on the different component. So the high strength is quite a major parameter or the property for the lubricants. Secondly, we have to also identify the lubricants with high flash point as well as the high fire point. Next, we must have the low pour point as well as the low cloud point for the lubricants. In this case, low pour point will give the better flow ability for the fluid, as well as the low cloud point will define the lubricating oil such that it will not go for early solidification. And at last, any of the lubricant which we are selecting, it must be chemically stable so that it will avoid the oxide formations inside the engines. Next, we are having the lubricants and the additives. Generally, lubricants can be liquid or can be solid or say semi-solids. Lubricating oils can be minerals, fatty, or can be a synthetic one. Generally, these lubricating oils can be prepared or can be manufactured from the animal fat or can be manufactured from the vegetables. Secondly, we are having the grease. Now, grease can be of different type, can be calcium soap, sodium soap, mixed soap, or can be of pure petroleum. So, these are the two types of the lubricants that we can utilize, lubricating oils as well as the grease. Now, for the better performance of the lubricating oils or the grease, these can be mixed with the certain additives. Now, here we can see that zinc ditinophosphate can be added to the lubricant so that it will improve its antioxidant as well as the anti-corrosive property. Secondly, we can add the organic acid so that it will improve the detergent properties for the lubricating oil. This property is quite useful because when we are supposed to carry away small metal particles or some foreign particles inside the engine, this particular property can be useful. Now, we can also add the chlorine to the lubricant so that it will work as a anti-wear property for your lubricants. Next, for the better viscosity index, high molecule polymers also can be added so that the viscosity can be kept moderate. And at the end, for a better pour point, we can also add the ester to the lubricating oil. Now, we will see what are the different types of the lubrication system. Lubrication system is classified as mist lubrication system, wet sump lubrication system, and dry sump lubrication system. First of all, we will discuss what is the mist lubrication system. This system is generally utilized when crankiest lubrication is not possible. In case of the two-stroke engines of the motorcycle, you might have seen that along with the petrol, oil is added to the fuel. The reason is that here in two-stroke engine, we are not having facility to have the crankiest lubrication. So we will see exactly what happens in case of the two-stroke engine. In two-stroke engines, as the charge is getting compressed inside the crankcase, it is not possible to have the lubricating oil in this sump. Hence, the mist lubrication can be adopted in such a practice. In such engines, lubricating oil is mixed with the fuel. The usual ratio which we are keeping for this is 3% to the 6%. Such a oil and fuel mixture is introduced inside the engine. The fuel which is getting vaporized and the oil in the form of mist goes via crankcase inside the cylinder. So the oil which strikes the crankcase holes lubricate the main as well as the connecting rod bearing, and the rest of the oil then lubricates the piston rings and the cylinder. Generally, the advantage of such a mist lubrication system is that it doesn't require any kind of pump, filter, strainer or any kind of the pressure regulator valve. So that's why it is quite simplest lubrication system. But along with this, it have certain disadvantages. Likely, it causes heavy exhaust smoke due to burning of lubricating oil along with the fuel. Secondly, since it comes in close contact with acidic vapors produced during the combustion process, so it gets contaminated and it results in the corrosion of the bearing surfaces. Now, we will see the second type of the lubrication system, which is the weight sump lubrication system. First of all, we will see what are the major components of the weight sump lubrication system. The components are oil pump, oil strainer, oil pressure regulator, oil filter, and one more diagram which I have added, which is showing oil holes inside the crankshaft. So these are the major components inside the weight sump lubrication system. Generally, a gear type oil pump is utilized in case of the weight sump lubrication system. Then we are having the oil strainer, which is a fine mesh screen which prevents foreign particles to enter inside the lubrication system. Then we are having the oil pressure regulator. The pressure regulator keeps the delivery pressure constant and can be set to a particular value. Next, we are having the oil filter. Most of the oil from the pump goes directly to the engine bearings, and portion of the oil passes through the cartridge filter, which is exactly shown in this slide. So this type of cartridge filter removes solid particles from the oil. The last diagram which shows that oil holes in the crankshaft. Here in this diagram you can see that the small holes are exactly drilled inside the crankshaft. These oil holes helps to carry out the flow of oil throughout the system, whether it is the splash system or whether it is the pressurized system. Now we will see what are the different types of the weight sump lubrication system. We are having the very first one, which is the splash lubrication system. Now in the schematic you are observing there is a oil sump. So this one is the oil sump, which contains oil strainer as well as oil pump. Oil strainer is work as a filter and oil pump provides the low energy for a lubricating oil. This oil sump is also called as a lower oil pan. In case of the engine, we are observing there is a crankshaft which is having the main bearing. Then we are having the camshaft. This one is nothing but the connecting rod. Oil troughs are nothing but the oil cups which are filled with the lubricating oil. Now the pressure inside the oil troughs can be observed with the help of oil pressure gauge. Here we can observe that the working of this splash lubrication system is quite simple. The pressurized fluid with a certain level in every of the oil drop is maintained. Now, when connecting rod is getting its reciprocating motion and that transform that one to the crankshaft in terms of the rotating motion. Because of this motion, this connecting rod with its big end always comes in contact with the oil drops. Now, whenever this big end comes in contact with the oil drops, it comes in contact with the lubricating oil. Now here, the connecting rod with its big end when comes in contact with the lubricating oil, it exactly splash, it exactly sprays that lubricating oil because of the motion which is observed with the connecting rod, which makes the lubricating oil to be get sprayed over the engine components. This type of lubrication system is exactly utilized for the light duty engine applications. Now we will see what is the second type of the weight sum lubrication system, which is the splash and pressure system. Now again we are having the same thing, that is the lubricating sum, which consists of oil strainer and the oil pump. Here we are also again observing there is a crankshaft which is having the main bearing, also having the connecting rod, and then this one is the camshaft. Now here we are not observing any kind of the oil drops or the oil cup, but the lubrication is carried out with the help of the oil jets, which are exactly sprayed over the engine components, which is more likely the connecting rod. Now how exactly it happens? Here you can see there are certain dotted lines. These dotted lines are nothing but the pressurized lubricating oil lines, which carry the pressurized lubricating oil towards the connecting rod, which exactly creates the oil jets towards the connecting rod and lubricate all the engine components. More likely, we are also having the same lubricating oil line towards the camshaft, which will also lubricate the camshaft and its bearing. So here, oil jets are exactly taking care of the connecting rod, main bearing, camshaft bearing. The third type of the lubrication system, which is the pressure feed system. Now here what we are having, again you can observe inside the lubricating sump we are having the oil strainer, then oil pump. Now here what we are having, the dotted lines are nothing but the header lines, or you can say the main line of the lubricating oil, which is the pressurized lubricating oil. Now this pressurized lubricating oil is made to flow towards the engine components, likely the crankshaft and its bearing, camshaft and its bearing. Now how it happens? Here we are having the lubrication oil sum, which is consist of oil strainer and the oil pump. Now this oil pump will pass that pressurized lubricating oil towards the header line, or you can say the main pressurized lubricating oil. This pressurized lubricating oil is further transferred to the crankshaft. The crankshaft, which is having the drilled hole in it. So the dotted lines here are nothing but the drilled hole present inside the crankshaft. So this pressurized lubricating oil is exactly supplied to the crankshaft and its hole, so that it will lubricate the crankshaft and its bearing. Also we are having the connecting rod. So whenever such a pressurized lubricating oil comes in contact with the connecting rod, it lubricates the connecting rod. Now this connecting rod, whenever it is having its reciprocating action, it splashes or it throws that lubricating oil towards the camshaft. So here you can see that there is a tappet and cam which are exactly receiving the oil thrown by the connecting rod. So in this way, this particular pressure feed system is working. Now we will see what is the dry sump lubrication system. In the schematic, you can see that there is a supply tank, there is a oil cooler, there is a dry sump, okay, there is a filter. There are two types of the different pumps which are utilized in this lubrication system. One is the oil pump and second one is the scavenging pump. Generally, the scavenging pump is having the more capacity than the oil pump. Now the oil which is dripping from the different components of the engine after lubrication is exactly collected inside the dry sump, but the scavenging pump works in such a way that it immediately removes the oil from the dry sump after strainer, and then it will pass that one through filter to the supply tank. Here near to the filter a bypass pressure relief valve is provided. Now in the case when filter is getting blocked because of the certain foreign particles, then the pressure which is getting generated after the blocking of the filter, it actuates the pressure relief valve and lubricating oil can be bypassed through the pressure relief valve to the supply tank. Now after supply tank using the oil pump, this oil is sent to the oil cooler. So generally it will be a water cooled or it can be a air cooled system. Now this cold lubricating oil is supplied to the different components of the engine, more likely bearing, and then it is again collected to the sump.